Welcome to Mavericks Academy. Code your destiny and shape your future with us.
Welcome to our very first lecture of AIML Professional Certificate, and today we are going to revise a comprehensive study plan. So now we are going to see about the curriculum of AIML certificate. So after completing this, your insights are about artificial intelligence and machine learning and its applications. So let me begin with this presentation. And what is AI? Artificial intelligence can be defined as a system that is used to mimic the humans or the activities of humans like reasoning, learning and decision making. Let us go through the text. AI is a branch of computer science focused on creating machines capable of performing tasks that require human intelligence such as reasoning, learning and decision making. So what are the types of AI? AI is categorized into different types, which is narrow AI, general AI and super AI. Narrow AI are the task that is specifically given to the AI systems or AI agents. But when it comes to general AI, human level intelligence, so it got a wide number of ratios and things that human can do, but superior to all the other different categories of AI, super AI, so surpassing human intelligence. So the things which the human cannot do, like let's say in layman terms, like calculator. For normal people, the calculations are different, but for a calculator, it can give the answer in seconds. So this is the layman example for you. So let us begin with this next slide. So machine learning algorithms. So there are three types of learning, which is supervised learning, unsupervised learning, and reinforcement learning. Supervised learning. Model learns from labeled data to make predictions. This is normal machine learning, how it works on unseen data. So let us explain this. There will be the existing data which we have given to the model, and the train file will be using that data. So the test file will be introduced to the new amount of data to predict the same. Unsupervised learning. Model discover patterns and structures in unlabeled data. Example include clustering algorithms and dimensionality reduction techniques. Reinforcement learning. uh, I can give you an example. Let's say yeah, professor is giving you a assignment, but you have made a mistake in it. So the professor will get learn you the things how it is going to be the correct. So it is a trial and error method. So it is a feedback mechanism on which the learning through an wrong answer or the right answer. So hereby the accuracy increases. So let's say we can include the example like playing AI and robotics game, etc. So what is deep learning? Deep learning is a part of machine learning which is more concentrated. So here comes the topic which we have introduced, which is neural networks. Neural networks is something like a model inspired by the structure of human brain, composed of interconnected nodes that process information in layers. Layers in the sense the level of neural networks, input layer, output layer, and a number of things. Conventional neural network. So there are numerous amount of neural networks. Let's say conventional neural network, deep neural network, um, and followed by artificial neural network, um, that is a GNN, graph neural network, and there are more. Let us see about two things. Conventional neural network, CNN, specialized for image recognition and computer vision tasks, employing conventional layers to extract features from the image. Let's say CNN is used to extract the leaf images for leaf detection. And recurrent neural network. Recurrent neural network is used to increase the progression, designed to handle sequential data such as text or time series by considering the past information in their predictions. So, for say, we can combine both the conventional neural network and the recurrent neural network, both to increase the lifetime accuracy. And data collection and pre-processing. So for all the things you need data. Data is a superior one. So based on the data, you are going to deploy the AML application or whatever. So what is data collection and pre-processing? Data collection is the thing. As I said before, you need a data to train the training file. So that is data sources. Gathering data from various sources such as database, APIs, application programming interface, or sensor readings, ensuring data quality, and relevance. You can collect data from any other sources, or also you can create a custom data set of your own. Data cleaning. After data collection, you need to clean the data. That is data cleansing. So identifying the handling missing values, that is null, outliers, and inconsistent data. To prepare the data for analysis and modeling. Data transformation. So up to this stage, we have collected the data, cleansed the data, and exploratory data analysis is done, and the data transformation. So you are going to transform the data or visualize the data. Scaling, encoding, and transforming data to improve the model performance and ensure the consistency in data units. So model training and evaluation. So you have collected the data, cleansed the data, and you have transformed the data into a finer enriched content. So now model training. You can write the train file and the evaluation file. So evaluation file in the sense test file. So model training, adjusting the model parameters using training data to optimize its performance on specific tasks. Model evaluation. So you are going to evaluate the trained model, that is we can say that is a pre-trained or a trained model. Accessing the trained model's performance using the metrics such as accuracy, precision, recall, and FN score. FN score is the last percentage. And hyperparameter tuning. And you got the answer, but you are not satisfied at it. So for this, you need a hyperparameter tuning. So fine tuning model parameters to achieve the optimal performance by experimenting with different configurations. Thereby you are increasing the accuracy and precision. So let us say an example, plan disease detection. So you have collected the plan data and exploratory data analysis is completed, data is cleansed, and data is transformed. So now the model training. You will be writing a file to get the labels and the data along the data set. So now the model training is completed. Single model training file is done. And after the second step, which is model evaluation. So for the model evaluation, you need to write a different script which is used to access the model to get the get the result based on the accuracy and precision, recall, and FN score. So what? And hyperparameter tuning. So we got a result like tomato scale, but the uploaded leaf is belongs to Apple. So you need to hyperparameter tuning. So fine tuning the models parameters to achieve the optimal performance by experimenting with different configuration. This is the thing which is hyperparameter tuning. I'm repeating it. So we are done with the AML, how it works and what is the characteristics of it. So now the real world applications. So where the AML will apply in the real world. Foremost thing is healthcare. So disease diagnosis, personalized medicine. We will be going through each and every project in this domain. Let's say we can roughly say a project based on this healthcare. Disease diagnosis. Let's say we are going to build a disease GPT followed by finance. So for finance, we can use credit card fraud detection using AML and e-commerce. E-commerce in the sense the e-commerce platforms like Amazon, Flipkart, and Myntra, etc. So recommendation systems based on the customer performance or customer data, also the customer expressions through the face, you can just predict the product and just say them this is apt to you. And transportation. Autonomous vehicles. So you can, Tesla, right? So Tesla is performing using Python and all the other libraries like OpenCV and machine learning, Keras, TensorFlow, used to predict the road data and vehicle sites and vehicle trajectory. Manufacturing, predictive maintenance. Let's say you are in a conveyor belt, we are just analyzing the single product, and the product is just go on moving on, and you are going to predict it is good or not, or it belongs to that product, or it's a different product. These are the different applications of AIML and the future of AIML. So why do you want to take this course? This is the correct slide to answer that. So advancement in AI. AI is transforming into AGI and ASI, which is artificial general intelligence and artificial super general intelligence. And ethical considerations, addressing concerns related to bias, fairness, and privacy. The data are kept normal or due to privacy issues. So you need to generate your own synthetic data that is used by AIM. So AI for good, leveraging AI to address global challenges such as climate change, poverty, and healthcare. That's all with today's lecture. Let us meet tomorrow. Like within 15 days, we will be mastering an AIML, that is artificial intelligence and machine learning. Hope you complete this certificate within 15 days. Maintain this streak to get good experience with the AIML. Thank you.
Welcome to Mavericks Academy. Code your destiny and shape your future with us.
Welcome back to day 2, guys. Today we are going to see about 3 libraries. So when the topic came to artificial intelligence and machine learning, you are concerned about the basic libraries, which is NumPy, Matplotlib and Pandas. NumPy is for data segregation and all other data related to the cleansing purposes. And Matplotlib, this is used to visualize your data. Let's say bar graph, followed by scatter chart and all the charts which related to the visualization, and followed by pandas. So pandas is a library which is used for data manipulation. Using pandas we can create a data frame, convert a CSV to data frame. So a data frame can easily access the data through the Python code. So now let's begin with the explanation of the code. So we are importing the numpy as np. So np is the alias name for numpy now. So array equal to np.array 1 2 3 4 5. These are the elements of the array. And we are going to print the array first. So after this, the sum of the arrays will be printed and the mean of the arrays will be printed. These are the inbuilt function which we have in numpy, followed by the reshaping of the which is 1 comma 5, and printing the reshaped array. These are the things which is with numpy. Let me run the code first. Yeah, you got it. This is the array, which is sum is 15 and followed by the mean is 3. So 15 by 5, which is 3, reshaped array. So this is the two, you can see the two brackets, right? This is the reshaping format of which is 1 comma 5. And let us replace the code now, followed by the matplotlib. So matplotlib.pyplot is a sublibrary or the function which is used for plotting the charts. So this is the x-axis and the y-axis. We are using the plt function.plot, and title will be simple line plot, and x-axis y-axis will be the x label and the y label, and the plt show function is used to show the chart. Let us run it. The numpy library is now executed, then the matplotlib library. So Python is a top-down approach. This is how it works, and you can see that all the things are like a line. Because of this, 1 2, the first are the normal series and the second is the even series. This is the ratio. So we are giving the y-axis as 2 4 6 8 10 and the x-axis as 1 2 3 4 5. This is the reason you get a single line. Now when I close this, there will be a bar chart. The reason is we are giving the categories and the values, followed by the plt.bar function which is used to create a bar chart. These are the simple things you can understand easily. So I'm going to cancel this. You will be getting a bar chart. Yeah, this is the thing which we have already explained, and followed by the pandas. So pandas is executed now. Let me explain this. So data, you are getting the data as list as of now. Let's say it's a dictionary. So now it is not a data frame, but after this line it will be a data frame. The entire dictionary will be converted into the data frame. So now we are printing the df. So df is data frame. You got the, don't confuse with the reshaped array, that is related to numpy. And now the data frame is printed now, which is the Alice 25 New York is the first row, and followed by Bob 30 Los Angeles and Charlie 35 Chicago, and followed by next function is print df.names. You are just going to print the names of the data, data types of the name, so which is object. The reason is that is a name, so you are giving the data type as object, that is automatically fitted by data frame using pandas. data with missing values. So you are going to copy the data frame with data with missing values variable, not a variable as of now. I'm just using this for understanding terms. It is a data frame. When you return the data type of the df with missing, it will return as data frame. And you are going to use the localization variable, which is one and followed by equal to none. You are changing the value to none, and you are now printing the missing values. Print df missing values. So the data with missing values is none. So followed by clean data frame. So what is clean data frame? So you can see the none value, right, in the first row, that is index of the first row on the edge of the second column. So this is a nan variable, which gives you the nothing variable. Let's say there is nothing, but we have mentioned it as no, not a number. So now you are going to clean it. So for cleaning purpose, you will be calling the old data. Let's say this is the data which we have 25 here, and but in this case you need to drop the entire column, otherwise the data will be entirely jumbled, and a major chaos will appear. So you need to pop this line out of the data set. So for this you need to use the function df with missing drop na. Drop na in the sense dropping the NaN values, not a number values. So thereby we have done this. That's all with today's topic. We have discussed about three libraries, which is NumPy, Matplotlib, and Pandas. Let me meet you on the day 3. Stay tuned.
Welcome to Mavericks Academy. Code your destiny and shape your future with us.
Welcome back to day 3, guys. Today we are going to see about how to load a data set, and how is the exploratory data analysis part is going to take place in AAM. Here the term exploratory data analysis in data science, but how it helps in AML. So for every AML application you need data. Data is a superior most agent here, which gives you the information, but in raw format. The processed data is known as information. So let me clear that how the process is going to be. These are the 5 bullet points, which is first you need to load the data set. So within the data set, you don't know nothing about it. Just you know the topic of the data set, but you need to clean the data. It has missing values, white spaces, and outliers in the sense that is not related to the topic which we have selected in the data set. So feature scaling and normalization. Feature scaling in the sense you need to extract your feature. Let's say you are going to detect the plant diseases. So you need a set of plant diseases and non-diseases. These are two things you needed. Balance out of this, you don't need nothing. So this is a process of future scaling, and normalization is a concept of let's say you are going to take 10 leaf diseases and 10 non-leaf diseases. Based on this you are going to predict the future leaves data sets, which is going to be diseased or not diseased. So this is the process of future scaling and normalization. Third part completed. Fourth part, encoding the categorical data, which is completely encoding the categorical data based on your encoding algorithm. Splitting the data into training and testing sets. What this means is, as I said before in the previous training videos, which you need two files, which is training and testing. You need two data sets, which is training data set and testing data set. So you need to split the entire data set into two halves. Let's say 80-20 or 50-50. That is based on your training model. um, let's say you are going to split it 50-50. So you are randomly giving the images to training module and the testing module. So this is the ending process of the model generation. This is how data works in pre-processing stage. This is the starting stage, not the end, so don't panic. Let us review the techniques of sklearn and combine with NumPy and Pandas. You are familiar with Pandas and NumPy as I discussed before in the day 2, followed by sklearn. Sklearn is a library which is used to exploratory data analysis, that is loading a data set, data cleaning and training the data set, and the entire machine learning process is under sklearn. Also there are different modules like TensorFlow and Keras, which is used for pre-processing and training the model and testing the model, and these are the three things: sklearn, Keras and TensorFlow. So let's say we are going to load the data set. We have a inbuilt iris data set, which is iris floor classification. We have it in sklearn. So let's say we are importing it, which is from sklearn.datasets. Datasets is a module in sklearn. We are importing the load iris function now, and followed by the iris dataset. Data is equal to pd.dataframe. We are converting it into the data frame where iris.data, and we are getting the iris.features names. This is the feature extraction, and you are getting the target column as iris.target, and followed by the localization variable which we have done in day 2, which is sepal length. Sepal length is related to the length of the sepal of a flower, iris flower, and we are declaring the feature scaling as standard scalar. Data scaled is equal to data scalar.fit. Fit function is used to transform the localization variable of the dataset, and followed by the bd.data frame. We are converting again this into a data frame. That's all with the feature scaling and normalization, and with this we are encoding it, and we are giving the sparse as false in encoder, which is one hot encoder is a function which is used to encode the sklearn module, and data.drop. So if anything happens in place of the species, it would drop the entire column. The encoding completed by here, and splitting the data. So normally we have a function called train test split in sklearn, which have the four splitted variables, which is x train, x test, y train and y test, which is used to calculate the accuracy efficiently. Also the training the model with the text size and the random state, and sklearn is used to only train the data textually and based on the images also. So you are going to print the training shape and the testing shape along with the resulting data sets. So this is the entire process of minimal data set training, that is pre-processing. Let us run it. I think yeah, we are good to go now. The file is running, and yes, we got the training shapes and the testing shapes. So based on the inbuilt dataset of the iris dataset, you have got the classes and shapes of the train shape and test shape. So this is how it works. So this is pre-processing. You are going to get the shape of the data by loading the data cleaning, followed by feature scaling and normalization, and the normalized data will be encoded, and splitting data will be about training and testing sets and displaying the sets of the data, and this will be carried out through the models generation module, which is you are going to generate a PKL model or a H5 model. This is the initial step to model generation. That's all with today's lecture, and let us meet in day 4. Thank you.
Welcome to Mavericks Academy. Code your destiny and shape your future with us.
And now we have completed with the pre-processing and the day 3, and welcome back to day 4. So today we are going to see about how to load a data set and split the data set and apply the linear regression model. So what is linear regression? Basically in machine learning you have four main algorithms, which is linear regression, random forest, SVM, which is support vector machines, and decision trees. Followed by, today we are going to see about linear regression model. This is the state where we have applied in day 3. Let us recall it, not a problem. And which is how housing, which is California dataset, California housing dataset, which is also inbuilt in sklearn. Actually, I have planning with the dataset which is Boston housing dataset, but it is removed in sklearn. So today we are going to with California dataset. So for this, you are going to drop the data. Med house val is a median house val. That is median house value. So the calculating the median is very easy now, and we are back with the same function, which is train test split, x train x test x train, y train y test. Text size is 0.2 and random state is 42, and model is equal to linear regression. This is the object declaration for model, and we are using the fit function for getting the same shape for x train and y train, and y predict is equal to model dot predict of x test. So this is the usual thing in linear regression. So you need to predict y using model dot predict x test, followed by mean squared error. So this is the value to calculate the accuracy and the loss percentage mean squared error. This is the function which you given with the y test and the y prediction. That is a model prediction of x test. R2 score. If you gone through the data science topics, you can gradually understand these terms, which is mean square error and R2 score. R2 score is used to calculate the predictions among the data which is provided. So hereby, after calculation, you are printing the mean square error and the R square error, and followed by the coefficients and the intercepts. Based on the R square and the mean square error, you can get the coefficients and the intercepts. Coefficients are nothing but the normalization of all the data, and the intercepts are the things which coincide with the coefficients. Let us run it. Actually, I have run it for testing purposes already. So let us explain this. So which is mean square error based on the already declared data set. R square value is 0.57 and something, followed by the coefficients. You can see that all the things are in exponential. Let's say exponential not 1 not 3. This is because of the huge data set based on only numbers. So sklearn supports a huge number of the decimal values only for prediction, and the intercepts value is always greater or always more lesser than the coefficients with the summation. So up to this, we have collected the data. First, we understand the AML concepts, followed by understanding the concepts of data collection and data pre-processing. And we have now predicted the model using linear regression. After this, you are going with the model prediction and training. That's all with today's lecture. Let me meet you in the new lecture of day 5. Thank you.
Welcome to Mavericks Academy. Code your destiny and shape your future with us.
Hi guys, today we are going to see about logistic regression. Day 4 is with linear regression, and today we are going to see about logistic regression. So what is the difference between two? So linear regression is entirely based on the linear line formula, which is yx plus c, where logistic regression is based on exponential terms. So let us begin with that. Usually we are going to set the target as iris and loading the iris data set, and here we are going to declare a binary target, so which is equal to 0 or 1. That is the target of the iris data set, and followed by we are training and testing the things, and usually what we have done in linear regression is going to be here, but just for declaration. So you are going to declare the model, which is logistic regression, and after this you are going to declare a function, plot the decision boundary, which is you are going to separate the target and the data. So this function define the decision of the boundary function. I can show you the output now. I've done a simulation for you guys to understand the boundary values, how it is going to be in iteration. So you can see the boundary line, right? All the points are being connected and the boundaries are being decided. So this is the area of prediction where all the things like sepal length and the sepal width is going to be coincide or the intercept. These individual points are the coefficients and the line which coincide are the intercept. This is just for simulation, and the output is just a graph. Let me show the original output now. uh, Before this I can just update this is just for the animation purposes, so not at all a problem for the related to this. Just leave this. we are running it now. And yeah, this is the original image, but we have simulated a thing to have just for understanding. So this is the boundary layer between the things of the sepal width and the sepal length. So hereby we are predicting the logistic regression using the decision boundaries values. That's all with the day 5, and let us meet in day 6.
Welcome to Mavericks Academy. Code your destiny and shape your future with us.
Yes, welcome back to day 6, and today we are going to take a quick review of what is decision trees and what is random forest. So these are two things which are balanced in our machine learning algorithms, and another one is SVM. We have done the things up to this. In next video we are going to see about SVM, and SVM is support vector machine. So let us concentrate through our day 6 now. uh, Usually we are loading the iris dataset and splitting the dataset into training and testing sets and using the train test split function, and we are now using decision tree classifier. So train the decision tree model followed by predict the decision tree model. As similar to day 6, we are using the y predict with the x test, and we are printing the tree accuracy. Accuracy can be given by accuracy score from sklearn library, and followed by the decision tree confusion matrix. So confusion matrix is nothing but this is the one. So it's about a indices matrix, more likely a diagonal matrix. Then after printing the CV score and the accuracy, followed by we are training the model using random forest. The same thing can be taken to random forest, linear regression, and logistic regression followed by decision tree. So this is the final thing. We are going to evaluate the same similar to the both the files, and cross validation for random forest and visualizing the tree. So what is visualizing? So you are going to use matplotlib for visualizing the entire decision tree. Let's say it's like a flow chart, but not a flow chart exactly. It is going to be decision tree. Let's say some binary tree. I will show you the output now. Let us first go with the textual. So what is the textual thing? Decision trees cross validation score, followed by the random forest accuracy, random forest confusion matrix, which is 10, 9, and 11 within the given iris data set, followed by the random forest cross validation. The same parallel things. And this is the random, it's a decision tree classifier in visualization using matplotlib. Let's say petal length is greater than or equal to 2.5, it falls behind else, and less than or 4.75, it falls behind this. Similar to all the nodes. Let's say this box is a node for every the area, and the line is the edges. One side is true and another side is false. After this, you are going to arrange it in a tree manner. What is a tree manner? Less than is in the left hand side, and the greater than is in the right hand side. After this, the elements of the tree. The first is root, and the last is leaf. The every last node of the tree subtree will be the leaf node. And there is parent and child. It is related to binary search tree. It is not related to this side. We are just going through the decision tree for machine learning purposes. That's all with today's code, and let me meet you in day 7. That is a last day of the week and the weekend. We will go through a professional project using machine learning.
Welcome to Mavericks Academy. Code your destiny and shape your future with us.
Okay, let me explain the day 7 goals. So today we are going to see about SVM, which is support vector machines. So what is a support vector machine? Support vector machine is a classifier which is used to separate the boundaries between the data. Let's say we are taking now the iris data set here. We are giving the x as iris data and y as iris target, training as usual, and we are using standard scalar, which is the calling function of the SVM, and scalar fit and scalar transform, which we have seen in the above code files, and SVM. Here we are going with SVM classifier with RBF kernel. So RBF kernel is a base boilerplate for support vector machine, and SVM classifier will fit the X train and Y train in with respect to the SVM variable, and we are predicting the Y using the X test of the predict function which is specified in SVM. and we are printing the confusion matrix in the classification report. We have run it here. Yeah, this is the confusion matrix, and the kind of let's say this is a classification report. It is more like a data frame which we have seen in pandas. So precision is one, and the reason is we are giving a limited data. So the precision and the recall, also the FM score is in one. Support is entirely calculated based on the data set, and the accuracy is about one for up to FM score based on the simple data. That's the thing which we have got 100 percentage. While you take a 1 to 2 GB data, the accuracy will be vary, and the support will be varied because of the jumbledness of the or the we didn't clean the entire data of the iris data set. That's the reason. And let me explain the code first after this. So plot the decision boundaries for visualization purposes. Up to this the thing is over with theoretically and experimentally with support vector missions. So we are going to visualize here. So how to visualize? Let me show the output once again. After the textual outputs, we are just visualizing this classifier now. So this is the region of violet nodes and the yellow nodes and the green nodes. So what is the purpose of the boundaries? Boundaries are just calculated using SVM, support vector missions. Uh, while the target and the data is iris.data, iris.target, which is x and y. That's the thing between this, and we are just showing the scatter plot with plt.show, followed by svm for plot, which is gamma is a scale. This is used for the color schemes and visualize the addition boundaries using only first two features. And plot decision boundaries extrain, and we are using the slicing variables, slicing the numbers in train and svm for plot. And hereby we are generating this graph with the with which is similar to k-means. We are just classifying, but whereas k-means is more advanced than svm, but svm is a base for k-means. That's all in today's session. We are completing a week for with the professional certificate of AIML. At the end of the 15th day, you will learn all the basics and the intermediate, also the advanced things. Like let's say you are going to detect an accident and to report the nearby hospital and the police station. This is the capstone project for you guys, and this hopes you help in the entire journey of artificial intelligence and machine learning certificate. Thank you. Welcome back to the course. That is, welcome back to day 8 actually. Today we are going to see about k-means and clustering. So what is clustering? The normal English meaning is cluster is to separate the things. Let's say we have 18 red balls and 18 each of 4 colors, which is blue, red and black and green. So you need to form a centroid, that is you need to separate all the fours into, let's say, a square. So this is what clustering means, separating the boundary layers of individual things. So yeah, like today we are going to use the same dataset which we have used for like for a week, which is iris dataset. That is inbuilt with the sklearn library that you all know. Followed by we are first loading the dataset, and we are going to apply k-means in that iris dataset. So followed by we are starting a for loop now, followed by what is k-means. So k-means are is a function which is deployed in sklearn. So k-means actually will separate the individual data within a boundary line that it requires as the parameters is number of clusters and the random state. So random state is where the individual centroid is being there, and the n clusters is the number of clusters should be separated. Let's say we have three number of colors, so three clusters will be there. That is the thing. So k means dot fit, which we have seen in most of the models, which is like fitting the entire data into the model. Followed by inertia dot append will be like all the three separations will be appended in the k-means. Followed by we are just plotting a elbow curve, and usually this method is called elbow method. The reason is I will show you in the output. As usual we are plotting the like a range and within the marker O, and we are labeling x and y axis followed by the title. So let me first show you this, then there will be number of clusters depending upon it. Let me run it. Yeah, like you can see the visualization, right? It is like looking like an elbow, so that is why it is named as elbow method. And secondly, this graph I will be explaining after the explanation. So yeah, we are given with the number of clusters is 3. So here we got k clusters. So how many clusters will be there? All the things will be done with the elbow method. And if the cluster is being recorded, that is like k is equal to 1 or k is equal to 2, then this method will be come into action. So we can just directly apply this k-means dot fit function to predict how the clustering is going to happen. That's the main thing between these two things. And you as usual scatter chart, and now you can know what is being happening here. I've explained about the centroids, right? So this is a centroid for green, and this is a centroid for violet, and this is a centroid for yellow, as usual. So these are the features, and these are the second feature. So you can see that like there is a boundary line for all the things, and the centroid is being placed in the center area of with respect to all the nodes. This is what k-means clustering means. So it will be applied in most of the machine learning methods for just for data allocation and data collection. Hope you learned something today, and we can meet you with the day 9 with a new machine learning topic. Thank you. Welcome back to day 9. Today we are going to see about principal component analysis. So this is one of the unsupervised methods. So it is a dimensional reduction technique used to simplify data sets. That is what principal component means. It find new axis, that is direction like x, y, and all the things that capture the most variance in data. That is the variability. Followed by PCA helps in feature extraction. That is the features of the model. That is, let's say it is going to detect something or predict something. Followed by noise reduction. Noise reduction in the sense reducing the noises, that is unwanted or outlier data sets that is to be removed, and improving data computational efficiency, that is increasing accuracy. And we have intern topics, so this dimensional reduction process of reducing the number of features, that is the, as I said before, we are going to do something that is the future, and while preserving as much of information as possible, that is the dimensional reduction. And followed by helps this helps in visualization, speeding up models, that is increasing the latency of models, and removing the noises. So we can see about PCA in depth. PCA is a linear technique that transforms feature into a new set of orthogonal components. Orthogonal in the sense form of 8 principles, followed by these components capture the maximum variance in the data. So it will be tending to a component which have a maximum variance, that is the variability. The first few components often explain the most of dataset variance. So all the components will be focused on dataset variance, followed by variance explained. Let's say each principal component explain a portion of dataset variance. We use explain variance ratio to decide how many components to keep. So it will be generating about 9 components or 17 components. Based on the variance ratio, we are going to final the number of components. That is the principal component analysis. For the explanation, we can just initiate it in the code. So as usual, we are loading the libraries and iris dataset. So the reason is why I'm using iris dataset is it is so minimal and you can understand all the things within that. So x is going to be the data and y is going to be the target. Followed by PCA. As I mentioned above, PCA is principal component analysis. I've explained all the things, what is principal component analysis, all the things before. So let me initiate with the code. So as usual in the previous day 8, we are using the same fit transform function within PCA. So this is similar to k-means, but there exists a difference between that. I will explain that. So as you like followed by a scatter shot will be displaying for this. At last we are printing the ratio. Let me wait for just a minute. It's being running. Let's wait for some time. Yeah, I think you got that. So this is principal component analysis. So for as of now, you can like we have loaded the iris data set and it is being clustered now. So this is the principal component 1 and principal component 2. There in k means it will be feature 1 and feature 2. All the things that are in k means are features, and principal component analysis is principal. Each will be considered as a principal and all the component will be analyzed thoroughly. So let me show you there. So after we can close this, you will get the principal component variance. So this is a variance equation, I'm sorry, various equation analysis between all the components, that is component 1 and component 2. Yeah, it is being like 0.9 to 0.05. This is the difference ratio, that is variance. Yeah, hope you learned something today. Let me meet you in day 10. Thank you.
Welcome back to day 10. What is reinforcement learning? Reinforcement learning is a type of machine learning algorithm where an agent learns to action in every environment. That is, it uses trial and error method to receive a maximized cumulative award. Let's say trial and error. What is trial and error? So a thing will be happen again and again until it is correct. So let's say imagine a car that is being like what a car does. I will be going through a road, right? So the main thing is you need to know the way. Let's say it is going to home. So until the correct path is being plotted, it is being go and crash and crash, and again it will be plotting the new let's say new way will be done there. So until the correct way is like got from the approach, it will be like using the trial and error method again and again, it will be executed. That is what reinforcement learning does. Let's say you can take while loop until it is became false, it is being executed again and again. That is what reinforcement learning. Take this as an example. A man is standing there and he want to know the way how to get home. So he he have a like option like he want to turn left or turn right. So what he does is he will be going straight. He will be taking right. So if it is the right way, he will reach home. Otherwise, he want to backtrack and get back in the same way. He want to take right. This is what reinforcement learning. So once it is get wrong, it will be backtracked to the current place, that is the previous place where he is being turned, and he will be turning right. That is what reinforcement learning means.
Let us initiate with the code. Actually, we have a problem here. As I explained above, there will be a path and the human will be there, and he or she might be finding the way to home. That is a thing. So here we are taking the frozen lake. Normally, frozen lake. A lake will be frozen in the winter area season, and now you need to find the path to the destination. The thing is, you need to use reinforcement learning, trial and error method. So we are using gem package, like gem module from OpenAI. So it is a model for especially for reinforcement learning, which have a problem like um, a source must find the destination through the frozen lake. So it has two conditions: is slippery equal to true or false. Is slippery equal to true means it is more difficult to find the path. It will be executing about a series of time. But false in the sense it is a normal path. No, not frozen lake is taken into this account. So for this, we are taken states and actions. So every state is where the person stops, and action is whether he or she taking left or right or the other path. So these are the states and actions, and followed by zeros. So we are representing the frozen lake path, that is successful paths in matrix. Let me run this before, and this is for slippery equal to true. So this is the thing. So you can visualize that it is being far more than decimals. So let me given false now, and let me run it. So as you can see that the number of zeros is higher than is slippery true. So slippery a usual thing. So when slippery does, it will be like it is difficult to find the path. So is slippery true? It is going to be like most efficient to find the path. That is the difference between two. So in between this, after arranging zeros, there will be alpha, which is learning rate, and gamma, discount factor. The number of episodes is equal to 1000. The number of like the events for episode in range episodes, a for loop will be executed here, and state as usual explained above, the number of actions. I'm sorry, the state will be number of events. So followed by done is equal, always is equal to false. Before the changes is going to happen, it will be false. So until it is becoming true, this while loop will be executed. So action is equal to np.argmax. So this matrix will be taken into account, the q of state, q learning of state, plus the random. So random integers, which is 0 and 1, and followed by the multiplication of 1 divided by episodes. Episodes is the number of episodes plus 1. So it will be incremented for every time, followed by next state, reward, and done. These are the three factors which will be available in every state and step. So it will be separated among next state, reward, and done. So followed by state and action equal to state and action plus the same number plus the alpha learning rate, followed by the reward plus gamma. So reward is the thing which is getting like the model will be getting in every event if it is correct, plus gamma, the learning rate. So based on the reward, it will be learned, followed by multiplication of np.max of either next state or state or action. So the after that, the train queue table will be given to you in the terminal. So let us run it now. Yeah, this is slippery false. It might be like overall zeros and decimal things. So the most decimal is slippery is equal to true. It will be slippery. Yeah, we got exponential values also. This is the thing different between slippery and not slippery. Hope you learned something about reinforcement learning. These are all AI essentials and machine learning essentials. Let me meet you with day 10, 11. Thank you.
Welcome back to day 11, guys. Today we are going to see about deep learning. So what is deep learning? Deep learning is the advanced form of machine learning. So machine learning is just for numbers and decisions. So yes or no, or it will be generating the numbers 0 or 1. So among this, on the selected cases, machine learning will return true or false. The advancement of machine learning is deep learning. So deep learning is built upon neural networks. Neural networks in the sense, like our brains are made up of neurons. So neural networks are made up of perceptron. Like for brain, it is neuron, and neural network it is perceptron. But the functionality of neuron and perceptron are similar. Perceptron is the simplest type of neural network. Takes input values, apply weights, passes through an activation function. That is, there are some activation functions like sigmoid, ReLU, all the things, and through this activation function, it will be applied and produces the output. That is the decision. And it forms a foundation of deep neural networks. That is, there are more than 4 neural networks. That is, conventional neural networks, artificial neural networks, deep neural networks, and graph neural networks. Followed by BAP propagation, core learning algorithm for training neural networks. Uses gradient descent to update the weights by calculating how much neuron contributed to the error. So there are separate functions for error, followed by work backward from output to input. That is the main matter here. So it will be work backward, like bottom to top. That is output to input. Followed by the images. So you can just compare the real neuron, that is a brain cell, with the perceptron. Let's say there are three main parts of neurons. That is dendris, followed by nucleus, and axon. It is a stem. So while compared here, the inputs are the dendris. So like dendris is especially for brain synapse, that is contacting the other neuron. So here the inputs will be contacting the output. So inputs are the dendrites here, and nucleus is the activation function along with the linear function, followed by the axon is the output. Now, yeah, this is the image difference between the neuron and perceptron, followed by input layer. So input layer is a thing where dendrites is, and followed by the weighted sum, and the activation function will be followed by the nucleus, and followed by the output layer, which is axon. This is the flowchart explanation. There are three activation functions based on non-linearity, which is sigmoid, which is represented as sigma of x equal to 1 by 1 plus epsilon of negative x in the power, followed by tan h. Tan h is another function which is represented by let's say tan theta, which represented by e power x minus e power minus x divided by the same between the negation, which is e power x plus e power minus x, which is represented in the quadrant form of minus 1 comma 1, followed by the sigma 0 comma 1 RELU. So RULU is the maximum of 0 comma x, which is most used in the deep learning networks, whereas sigma and tan h will be least.
Let me start with the code. Initially, we are importing numpy like for the functions like array, and followed by sigmoid function and sigma derivative. So sigma activating function followed by the derivative of sigmoid. So first is initiation function followed by the derivative function. So input dataset is, as of now we are giving a random dataset which is yeah, identical matrix, and output dataset will be set for y, which is x and y will be the main axis and the data sets, and followed by random seed is used for random numbers should be allocated, and followed by we need to initialize weights. So as of now as we discussed, initially the input will be given to the perceptron and the weight will be added and the output will be given. So uh, between this the weight adding the weight is known as training. So weight input hidden and weights hidden output. So input hidden and hidden output, which means input will be given to the weight and weight will be applied to the output. So initially to 2-star NP random, which is usually for 2 power on the weight, followed by the training loop. So initially we are, as of now over 4 classes we are using the for loop for training, and for approach equal to 10,000 steps, followed by hidden input and hidden output, followed by final input and final output, like np dot which applies the weight, followed by the sigmoid function which will be call upon this function, written 1 by 1 plus np dot exponent of minus x, which is sigma activation functions formula, followed by error y minus final output. As we explained above, there will be a error directory where all the errors and the accuracy will be stored, followed by hidden error and hidden delta. So delta is the difference between the sigmoid function and sigma derivative, followed by weights hidden output, like plus or equal to it will be added again and again within the loop, hidden output and hidden output of the delta, followed by input hidden will be added with the hidden delta. So respectively both will be added again and again within the loop for the increment factor. So at last it will be given output a round value of final output will be which will be the training data. Let me run it. Yeah, we got the 4 values for it. So why the 4 values? The data set is 4 and followed by the output data set 4. So that's the reason we got the output. That's all for today. We have learned about perceptron and how perceptron is different from the real neuron, and how to like create a sigmoid function and its derivative, and we have trained sigmoid using sigmoid.
Welcome back to day 12. Today we are going to see about deep learning techniques using Keras or TensorFlow. So what is Keras? Keras is an API which is user friendly that simplify building, training and evaluating neural networks. So it allows fast experimentation, which is like training a model to building a deep learning network with standard model components like layers, activation, and optimizers. Used with TensorFlow, it powers most modern deep learning networks and application from image and speech recognition to language modeling. So, what is this actually? You can see the nearby image, which is input will be given to the future extraction. So, future in the sense the what is your model is going to do, that is the future, and it will be classified. So, the first three dots is the input layer, the middle three dots is the middle layer, that is the decision making layer. The third layer is output layer. So followed by the input is given as car. So it will be feature extracted, classified, and car not car are the two things which is going to be held in output. Followed by this is machine learning. Deep learning is what is the feature extraction and classification will be binded, which will be as a layer. So input will be given to the deep learning model, which is feature extraction plus classification. There are more two other layers, which is middle layer, followed by core or not core, which is the output. So this is the advancement of machine learning with deep learning.
So let's start with the TensorFlow. TensorFlow is a as usual, we have used iris dataset from sklearn library. Here we are using mints library, mints dataset from TensorFlow library, followed by xtrain and ytrain as usual in sklearn, and xtest and ytest. Followed by equal to means dot load data. We have loaded the data. Followed by the xtrain will be 255 and xtest will be 255 normalization. Followed by reshaping. So in TensorFlow, reshaping plays a vital role. Otherwise, you will be like ran into an error. So reshaping matters with respect to the given data set. So after this, we need to category. X train will be categorized into Y train, and Y train will be categorized into Y test, and followed by building the model. So as usual, we explain networks, that is neural networks are built by layer. So layer dot dense in the sense it will be given like in the 2 to the power of, that is multiple of 2 with the activation layer. We have this I'm sorry, explain like the activation functions, which is RALU, sigmoid, and all the things. Input shape will be 784 with respect to the X train and Y train. Followed by we have built the model now, and we need to compile it as usual. Followed by model.compile optimizer Adam. There are more optimizer like 2 to 3 optimizer we have chosen Adam. A loss is equal to categorical cross entropy. This is a mathematical function which is especially for loss. Followed by metrics will be accuracy. Accuracy will be given, followed by the loss. Optimizer will be Adam. This will not be given in the terminal. Terminal will contain accuracy and loss only. So we have done, let me repeat the flow. We have pre-processed the data, loaded the data, pre-process the data, build the data model, compile the same model, and we have need to train the model, which is model.fit. So x train, y train, epochs. Epochs in the number of training which will be done in a flow. Batch size will be, each epoch will be run for a period of 32 seconds, which is 32 epochs. Validation split is 0 0.1. Each data will be splitted into 0 0.1 length. Followed by evaluating the model. Loss and accuracy will be calculated here, and the test accuracy will be written as the lost. Let me run it. So these two are the just environmental variable warning. That might not be a reason for errors. The efforts started now. As I said above, accuracy and loss will be calculated now. Respect to the value accuracy and value loss. As this is a small program, the approaches is being run very fast. For a machine learning model, it will take about 1 to 2 hours. The accuracy is 97.08. As we like run for 50 times, it will be like about 100. Might not be a problem. I think you have learned today about TensorFlow and Keras. Using both the things in machine learning will be very powerful. That's all today's topic. Let me meet you tomorrow.
So today's topic is CNN, a conventional neural network, which is a type of neural network, a deep learning model designed to automatically and adaptively learn spatial hierarchies of features from images. So a neural network is especially for images is CNN, conventional neural network. It uses layers like conventional and pooling to reduce number of parameters and extract meaningful patterns, which means what is a neural network according to us from the before video, which is input will be given, weight will be applied in the input, and output will be delivered. So what differs CNN from the normal neural network, which is a type of neural network, but it has some extra features which distinct it. So input will be given and followed by it will be like arranged in a conventional manner. After that, it will be pooled. So pooling is area where it will be arranged in a certain manner to connect all the nodes. So all the nodes will be connected. So after the connection, it will be giving the output properly. So it will be combined with future extraction and classification, so which we explain in deep learning model. So this is the difference between deep learning and machine learning. So input conventional pooling will be under the feature extraction, and followed by the fully connected layers, and the output layers will be like come into classification. After that, the output layer will be given. So this is what CNN.
So as we done with the CNN explanation, we can just initiate with the code. So as usual, we are importing the TensorFlow and Keras, followed by the Minst model. So for, after that, we are loading the data and pre-processing the data as usual. And now we are building the CNN model. So with this, as I explained above, there will be a max pooling and density layer. So which is con2d layer followed by max pooling layer. Again, con2d will be done for this same thing, but once it will be done in the 32th place and like 32nd place, and it will be done for the 64th place. So which will be the like class size, and the activation will be RALU followed by the input shape will be given 28 28 comma 1 as we explained above. After that, we will be flattening the max pooling followed by the density layer as usual in day 12. We have used density layer for both of the things, which is RELU and softmax. I didn't explain what is softmax. It is advancement of RELU. We are comparing the model again with Adam and categorical cross entropy, and metrics will be always accuracy, and training the model with model fit, which will be x train, y train, and approaches is equal to 5 as usual, and batch size will be 32 here. Loss and accuracy will be calculated and it will be printed now. So let me run it. Here you will be seeing a far more difference. Like while using sigmoid function, you will be getting the accuracy like 0.97, but you will be getting a slight rise in the accuracy rate. Let us wait for some time. It will be like 10 to 20 seconds. Let me skip it for seconds. Let me show the output. Yes, we got a slight accuracy changes here. So this is the difference between a normal activation function and CNN. So activation function is what a machine learning model. So neural network will be a neural network, like it will be of deep learning. That's all for today. Let me meet with a new topic tomorrow. Thank you.
Today's topic is recurrent neural network. So it is a type of neural network. So we can explain with the example. So which is LSTM. What is LSTM? LSTMs are the recurrent neural networks. The full form is long short-term memory. Designed to learn from sequential or time series data by maintaining long-term memory, they solve limitations of traditional RNNs. So it is a traditional RNN in the sense LSTM. So the competition is between LSTM and RNNs. So it is an advanced form of RNN. Also, it is using RNN. The LSTMs are widely used in stock forecasting, language modeling, and time-based predictions. As you can see in the image, a neural network will be there, but the thing is, it will be looping around and around till the accuracy is met. That is the difference between recurrent neural network and other neural networks.
Let me start with the code. As I explained above, RNN are the things which we are repeatedly executed between the neural networks. So as usual, NumPy, TensorFlow, and
here the new thing happens, which is LSTM will be taken from the TensorFlow and Keras library. So we have created a new function for sine wave. So sine wave, in the sense, LSTM will be based on the sine wave, which is based on sine theta and cos theta, and this line space will be like 0, 100 and 1000. This is a space between the waves, and followed by uh, y will be the sine wave of x, and xy will be initially empty, and for I in range within the length will be differentiated from the sequence length. X will be appended with the sequence length within the I, and it will be sliced. After this, Y will be appended with the sequence length with the increment of I, followed by return. The function will return the NP array of X and array of Y. X array and Y array will be returned. So this is a function. It will be called between the main function. We have sequence length of 50, and X and Y will be generating a usual sine wave, which will be calling this function. The sequence length will be given in the fit function, and followed by we are reshaping it now. So the thing is, as I mentioned above, the shaping will be a matter in deep learning. So the shape will be perfectly fit within the model, otherwise it will be running into an error. So followed by split the train and test data set. It will be a single data set. We are going to split half by half, which is 0.8, which will be the value of alpha. X train and Y train will be splitted now, and as usual test for X and Y. So we are building the LSTM model here. Model is equal to sequential data, which is LSTM will be falling under the sequential model. So sequential of LSTM 50 sequence layers, and the length input shape will be sequence length comma 1, followed by the dense layer is 1. That is the definition here. We are compiling the model with Adam, and last model will be MSE, mean square error, followed by model fit, which will be containing the X train, Y train, followed by the approaches will be 10, and backside will be 32 as usual. Predictions will be done, and we will be plotting the graph here. Let me do it. Approach is started now. Yeah, it is being fast. So LSTM will be fast compared to the CNN. Yeah, we got the sine wave. So this is a LSTM time series predictions. Yeah, that's all for now. Let me explain the capstone project tomorrow. Thank you. So we are at the last phase of our course, which is capstone project. So I have explained all the things like CNN, RNN, neural networks, machine learning, basics of machine learning. So these are the things which we are gonna use in this project, which is capstone project. This is a end of a course. You need to develop a AI powered tool that detects plant or crop disease from leaf images and produce fertilizer or pesticide suggestions based on the detected disease and region. So this is the topic, and the concepts will be used in this CNN, k-means, LSTM, Keras, and data preprocessing. These are the data which we have, like data are algorithms which we have used in the previous videos. That is, you have learned all the things. All the best for the capstone project. Do it well. Thank you.